Okay. All right, that should be fine. Hello, Ivan. How are you, my friend? I could be better. This has been a rough day with my interwebs. Yeah, my internet. I guess they were doing work outside or whatever. They've had technical issues all day. So my internet went out for like 2.5 hours. I had to cancel the first class. Was able to get the second one in, and then Um, and then now it's starting to work again, but I don't know. I called the Comcast guys. They're like, "Oh, we just have a technical problem in your area." So I was like, "Well, what time?" This is by 6:30 p.m. And I'm like, "Well, it's gonna be hit or miss whether or not the internet would work." And fortunately, it does. So I'm happy about that. Um, you know, yeah, I'm relieved because then I can, I could talk to you, I could talk to others. I know that typically, I don't cancel class whatsoever, so unless there's a darn good reason. So, um, internet out of my control a little bit. So if we met face to face, you know, yeah, I like coming to this class. Well, at least I hope you like coming to this class. Go do this here. Okay, 460. Get this here. Sorry about the wait here. Let's get in this here. There you go. Right on. I appreciate that. Hopefully the other guys will see my push notification and they'll say, "Oh, yeah, you're actually back." All right. Any plans for the weekend there, Ivan? Oh, is it because of the is it because of the COVID restrictions there? Yeah, that's a bummer. Well, you know what? Maybe you can order breakfast and then just kind of eat together, in a separate area. Yeah, I know it's not the same as like sitting in a restaurant. That sucks. Yeah, that's not a bad idea. Although, do understand, Lake and McHenry County have the same kind of shutdown, so going there probably won't work. I don't know about DuPage yet. Driving is the easy part. Finding a place may be the hard part. Yeah. I mean, I just was at Walker Brothers actually this weekend. But yeah, yeah, I can't do that now. Although they will let you order out here in Schaumburg. So, we're talking about, hey, Gustavo. Yeah, we're talking about like the shutdown restrictions, being put back in place. Yeah, I like that. Walker Brothers is really good. I haven't been to Wildberry in forever. Chiaquies with brisket. That does sound pretty good. I've never tried, but that does sound really tasty. What are we waiting for? We're waiting for Diego. And soggy tortilla chips and salsa. Can't really argue with that. Can't argue with soggy tortilla chips and salsa. It's the best combination there is. Oh my gosh. Okay. You getting hungry now? That's true. Let me get this out. This is for the class. So there's Diego. How you doing, Diego? You doing good? I'm late. No. Yes, my internet is working, but if it suddenly magically kicks out again, then I'm sorry. I have no control over that. My last class, it was actually just kicked off, and it's like, yep, you got it done. Now you're done. got just got done eating some KFC, Kentucky Fried Chicken. There you go. Kentucky Fried Chicken, the best place to be when you want to get. Their famous bowls are really good. I actually like those. Like I know it's not the best food you ever eaten in your life, but still, meh. It's got its perks. All right. Yeah, pretty much. It's all right. It's not like the best. I'm doing pretty good today. Doing pretty good. Hey, Tal, how's it going, my friend? How we doing, buddy? Uh, why? Why? Wait, why? Why? Okay. How's the date thing going? Hey, Anna, how are you? How are you? The date thing going is not going anywhere at this moment in time. It was only been one day. And I literally haven't done anything outside of just complain that I didn't have internet. Found any? I haven't even done anything. Eventually, someday. Spent the day. Oh my gosh. Spent the day at the DMV. No. I promised you. It wasn't today that I promised you that would happen. Where'd you get that in your mind? All right, that's cool, bro. Oh, okay. That's got man. The DMV is never fun. You gotta sit there, take some kind of ticket, stand in line, wait for your number to be called. And they tell you take some random picture, bump, bump, bump. You're like, okay, fine. In Illinois, they're like, yeah, you gotta take off your glasses. Yeah, maybe you went at the right time. DMV is just a, ugh, just got a bleh and a whole lot of yuck. All right, everybody. All right, I think we could do this. Yeah, it is. It's pretty slow. It is a lot better than it used to be. I will say that. At least here in Illinois. But I can't speak for other states. So, all right, everybody. Let's get this ball rolling. All right. Okay, let's get started today. Welcome back to Wednesday, end of the week time today. So today, we are going to finish up here chapter 7. All right, so chapter 7 is on the agenda here for today. We're going to do the latter half of chapter 7. Just taking care of 7.4, 7.5, and 7.6. Essentially, a lot of the things we'll be doing, again, reiterating of what we've already talked about before. But 7.4 here, let's go ahead and talk about that. That was talking about two-step operation questions. Okay, so that's what we're going to be doing here in this first go around. So yeah, let's do that here. Now I'm planning to get a better monitor, or at least a bigger, wider monitor eventually. So these could go by a little bit smoother. Okay, So that's essentially what we're going to be doing here. Now, I'm going to get one of those wide curved monitors so you guys can see a little bit more of the screen or something like that. Maybe that'll be a little bit better. I don't know. Uh, that's what I'm kind of thinking. So, all right. In any case, let's go ahead and do a problem out here. Why not? Okay. Oh man, this is the part where I really don't like. All right, this book. Let me tell you. All right. So let's go ahead and do some of these problems here, and we'll see exactly how to work them out. It shouldn't be too hard to do, but let's see if we can fit this into the page. Oh, that's no. Yes, yes, yes. This thing. Yeah. Look at all the hard work you do, hitting buttons. All right. Good job, Ali. You're the best. All right. All right, let's take a look here at number 1. So a repair service charges $45 for a house call and an additional $60 per hour of work. The formula T is equal to 45 plus 60H represents the total charge T for H hours of work. If the total bill for a customer is 375, how many hours of actual labor were there? So again, this is going to kind of reiterate what we talked about last time. What was the important point here to keep in mind here is key is, again, to know what the variables mean in the uh, in the in the formula. And of course, key number 2, as we've always set out to be, say this again, balance is our key. And once again, that isn't going to change. Balance is still going to be our key there. All right. Let's take a look at this and let's do it out. Okay, so we do have a formula here. In this particular case, it's going to be T is equal to 45 plus 60H. And we have a total here of our total bill was 375. So T here is going to equal 375. Okay, that's what we're given here for the bill. So what we're going to have here is we're going to have 375 equals 45 plus 60H. Okay, and what can we do next? How can we solve for big H here? What should we do first? All right, subtract 45 on both sides. Exactly, good. So again, we just want to go ahead and just get rid of our first roadblock, which is that 45. So again, the balancing out here, we get 330. Okay, and what comes next? Divide both sides by 60, okay? Good. Okay, and what is, okay, what's H equal to after everything's said and done? What is H going to equal to? 5.5, all right, good. So 5.5 hours worth of labor, there you go. Winner, winner, chicken dinner. All right, let's go ahead and do another one here. And let's go ahead and met this out here. Yeah, so that'll be the next one there. Okay. All right, so the next one I want to do, there's a specific one I want to do, so I'm going to do that one like I want. Okay, so we're going to do number 15 here. Okay, so all right, so we're talking about the air leakage here. So okay, so ACH of a house is a measure of its air tightness. Okay, the formula for ACH is equal to 60L divided by V, where L is the air leakage in cubic feet per minute and V is the volume of the house in cubic feet. If a house has a volume of 25,600 cubic feet, what is the maximum amount of air leakage that would result in an ACH of no more than 25? Okay, so let's write down this formula here. ACH is equal to 60L over V. All right. Okay, well, what should we do next? What numbers need to go in what places here according to this problem? What numbers need to go in place of this is the question. You guys tell me here. What numbers go where? All right. Yes, V equals 25, 6. That's true. So what we have here is 25, 6. All right, I agree with that. Cool, cool. All right, and what else? We got 60 on the top here, 60L. What about ACH? What's that equal to? Yep, 1.25. That's correct. That's correct, Diego. We don't want it any more than 1.25, so we're just going to set at 1.25 to be our like upper limit. All right. Okay, so we want to solve for L here. What do we do first? How do we solve for L here? Again, remember balance here. So remember that you're dividing by 25,600. So that's correct. We're going to multiply by 25,600. But of course, what we do on one side, we have to do on the other side for the sake of balance. Has to happen. All right. So that goes away. So let's do that on the calculator there. That's strictly a calculator thing. 32 grand. All right. I take your word for it. 32,000. $32,000. All right. All right, and then we're going to repeat the process here. I think everybody knows what will happen next. Take that 60 there, say goodbye to Mr. the 60. Fine, fine, fine. All right, so we got 60. And then we're going to get an answer for L here. Again, use your calculator for that. And what do we get? What is L going to equal here? 32K divided by 60. 533.3 repeating. Okay, good. That's right. So then you get 533 and a third if you're doing the mixed numbers stuff. Rarely rare that you do this, but again, whichever way they decide to want you to write it out on the homework, you'll know which way. All right. All right. Any questions? Any questions about that? Nope. It's the KFC gives you more smarts. This is what it does. Look at that. All right. Okay. I have to make sure I send that over. All right. So much work, so little time. All right. Let's move on to the next section here. Next section. All right, so section 7.5 and 7.6 is basically more equations and more word problems. So section 7.5 and 7.6, basically more formulas and word problems. So we're going to once again do a couple more examples here from each of these sections here, respectively. So let's do it right now. Okay, so let's go to this. Okay. All right. Now, remember how it works in this case. Now, I remember we did number 7 here, but I think we did number 7 or something to that effect. Something fairly similar. Oh, no, we did number 12 there. I remember that. But again, remember, everything is balancing out, okay? That's still going to be the key. We're not going to treat the letters anything differently than what we do with numbers, okay? So remember, that was the key here in this section. I remember distinctly writing this one out. And that is, again, the key here is to, treat variables as if they were numbers, okay? You may not be able to combine them together in like terms or anything like that, but they are going to be moved on to the other side the same way you would if there were just regular numbers there, okay? So if we look at it that way, let's go ahead and give it a try here. Let's go ahead and do number 7, actually. And let's see how we can we go along doing that particular problem there. All right, so all right. So here we're given a formula here, so let's do that. Right now, let's write it out. So we get C here is equal to AD over A plus 12, okay? And let's see here, they want us to they're asking us to solve for D. All right, we're going to solve for D. Okay, so if we want D is equal to something, okay, that's what we want. Now, it's not necessarily a number in this case. Again, it's going to be in terms of the other letters that we see here in this particular problem. But let's go ahead and try that out here in this instance. So if I need to solve for D here first, what should I do? What do you think would be a good idea if I want to get D here first? What do we do first if we're going to be able to solve for capital D? Okay, what are we going to do with A plus 12? I agree. We are going to do something with A plus 12. What should we do? Now I put parentheses around A plus 12. That should be a little bit of a hint there for you. Remember what we did in the last problem, okay? Divide. Well, this is already divided by the quantity a plus 12, and that's standing in my way. So it's already being divided here. What should I do instead? That's right. Now we should multiply here. That's correct. Okay. Again, it's just like the 25,600 in the last problem. Well, we multiply by 25,600. So let's imagine that a plus 12 was like 25,600. Well, then the process is no different. I'm just going to multiply by the quantity a plus 12 instead of 25,600, as the last example showed. That's it. Like, I don't know, people try to make it more complicated, but it's not that complicated if you repeat the same thing that you did in the last problem. It's the same exact method. There's actually literally no difference. Here we'll distribute the c here to both of these terms, okay? So we're going to get CA. Oh, it would be helpful if you guys could see that. No wonder. Okay, my bad. All right. So you get CA over, not CA, yeah, CA, but plus 12C equals AD. Okay. And then what do? We're trying to solve for D here. So what's our last step here? All right, just divide A, right. So we're going to divide by A. Again, we're going to divide everything by A here. And this is going to be our answer. So this is our answer for D. Will be CA plus 12C all over A. Okay, good. Now it does ask us a second part here, so it does ask us here, that's part A, by the way. Part B is just basically kind of plug and chug. So they say, all right, well, find D if C is equal to 0.05. So D equals something if C equals 0.05 and A equals 7. So all we have to do here is just plug it into the formula we found in part A. All right, so this is 0.05 times 7 plus 12 times 0.05 divided by 7. All right, and again, you can bip bop boop in the calculator there. What was that? 0.35, that's 0.6. So that's going to be 0.95 divided by 7. All right, so how many decimal places do you want us to go to? D, here's the adult dose. Okay. So here we're going to get 0.136 or 1357. Yeah, we'll just go with that. So a 0.1357 is what we have here. Okay, that's fair. Okay, yeah. Both are just fine. Not a problemo. All right. Any questions? Any questions about that particular problem? I remember doing that one. Cool. Any questions about any questions so far? All right. Yeah, of course you can add something, Anna. Go ahead. I'm trying to get a letter to one side. It looks like what you did. Oh, okay. You mean did I forget that? Are you talking about like this part here? Like the oh, man, sorry, I messed that up there. If you're referring to that, Anna, like just kind of canceling that out, I just forgot to just cross that out. That was my bad. Oh yeah, then that's my fault. I meant to. I should have crossed that out. No, you're right. You're right. You're right. You're right. I should have crossed that out. Yeah, that would make it less confusing that way. I agree with that. I usually do. Like I crossed out the A's here, but I didn't cross this out for some reason. Yeah. Now you're confused. All I did was just cancel it out on this side, and then we multiplied by a plus 12 on the other side. That's why we multiply here and we multiply here, and we put it on the same line, is what Anna's saying. So what she's essentially saying is this. Yeah, okay. So what she's essentially saying is this is probably to make it a bit easier, and it's a very valid point, most definitely, and it could be very helpful, is just to put a plus 12 on the same line here, just like so. So that way, if you know that you're multiplying, again, you're just doing like the balance. So like if you know that a plus 12 is on the top, then you know that a plus 12 here is on the top as well. So it helps keep you organized in terms of how you would approach the problem. So yeah, definitely very, definitely a very good point. Thank you, Anna. Yes, this is very true. Organizing yourself in later math is extremely helpful. This is very true. All right. All right. I love the tips. That's very good. Very, very helpful indeed. All right. Let's try and do one more here from this section. And we'll do the next one here. Yeah, see, that's the nice part about this class is like, hey, it's a collaborative effort. Although we know, you may know the material, but sometimes other people catch what I make mistakes with, and I forgot to cross that out, and that's a very good catch. Absolutely. I always appreciate the help because, I'm just one person. I try and apply as much as I can, but the more eyes that there are on it, the better. I think that's great. We're here to help each other out, so I'm really happy about that. Okay. All right, let's take a look here at this roofing problem. That'll be the next one here. Um, Number 11. The formula L is equal to U times R plus H is used to determine the rafter length L of a roof, where R is the run and H is the overhang. The quantity U represents the unit line length. When the run and the overhang are in feet, the rafter length will be in inches. If a rafter 247 inches long is used on a roof with a run of 16.5 feet and U is equal to 13, how long will the overhang be? Okay, a lot of stuff going on in this problem, but let's go ahead and at least define some of our letters here first and foremost, okay? So what we're given here right away, let's just at least break one thing down here, is we're given U here right away is equal to 13. Okay, so we're given that. Okay, now, what other letters are we given here in terms of a value? So we have U is equal to 13. R is equal to 16.5. Right, R is the run. Okay, so R is equal to 16.5, so 16 and a half. Okay, I totally agree with that. All right. And what else? Okay, that's right. So one of the things that's important in this problem where it could trip you up is L. L is indeed 247. Again, the reason why in this case it's 247 is because in the problem it specifically stated that it specifically states that we have the length of the roof here, but again, the rafter length will be in inches when the run and overhang are in feet. So it is designed that way to be in inches according to the problem that we see here. So now we can go ahead and plug in some numbers and let's see what we get. We need to find h, so we'll have 247 equals 13, that's u, times r plus h, so r is 16.5 plus h. So the only thing that we have left over is, of course, the h part there. Now, admittingly, there's a lot of different ways to go about solving for h here. There's several ways, actually, you can solve for h. But let's pick the most direct approach here, at least. Don't want to make it too confusing necessarily. So what a lot of people like to do is they just take that 13 and distribute it to both the 16 and a half and the h. Okay, so we take, so we'll just multiply that, 13. I accidentally did that. Okay, so here if we multiply 13 times 16 and a half, that's 214 plus 13h. And that's going to equal 247. All right. So the reason why a lot of people like doing this is because for them, they can easily see possibly what the two steps are that they'll need to do in order to solve for h. Okay, so what do we do next here? Did I, thanks. That should be 214 and a half, right? Uh, Let me check that. Maybe I just missed it. Oh yeah, I did miss it. That's my fault. All right, thanks, Diego. That's right. And Ivan, you're correct too. So this should be, let me get an eraser for that. There we go. Then I also agree with Ivan here, be 2 minus 214 and a half on both sides. Okay. All right, so we're going to take 247, subtract it by 214 and a half. All right. So we're going to get 32.5 equals 13h. All right. What's the last step here? Okay, good. So we're going to divide by 13. All right, and h is in D, h is 2.5. Okay. All right, so 2.5 feet. Good. All right, and that's our final answer, 2.5 feet. Any questions about that? Well, Gustavo just told you no, Diego. Okay, so that pretty much is like some more equations there. Certainly can talk about those. Those aren't too bad. Now, fair enough. All right, let's go to the. It's okay. That's all right. Okay. Okay. Let's go ahead and take a look here at this last section of chapter 7. Okay. The last section of chapter 7, har har. The last section of chapter 7 is going to be word problems, okay? All about word problems. We've been doing all word problems pretty much in this course for the most part. Um, Now, let's go ahead and take a look at, it's the last section, not the last chapter, my dude. That's chapter 10. Don't forget. Um, okay, so we have, let's go ahead and do one of these problems here. Last section for tonight, that's true. Okay, we're already there. Got a couple of these problems to do, and then bada bing, bada boom, you got it. All right, let's try this first one here. Let's see, which one do I want to do? No, we did that one, so I'm not going to do that one. Okay, let's try this one here. This is a slightly tougher problem here, so let's imagine this one here. There are 156 concrete blocks available to make a retaining wall. The bottom 3 rows will all have the same number of blocks. The next 6 rows will have 2 blocks fewer than the row below it. How many blocks are on each row? A little old school like that. That's what happens when you're born in 1979. You get the best of both worlds. All right, so the next 6 rows will have 2 blocks fewer than the row below it. Again, how many blocks are in each row? So we're given a total of 156 blocks. And we know that for whatever reason, again, we do know that there's 2 fewer blocks in the row below it. So let's at least draw a picture here about what this will look like. And then this will make a lot more sense. So in this case, this would be one of those problems where being super visual is very, very helpful. So we have three rows of bricks, okay, or blocks. They're all the same size. But then the next one above it, so it says the next row will have 2 blocks fewer than the row below it. So it's going to be, again, it's going to be this much here, again, -2 from the one below, okay? And then this one here is also minus 2 from the one below. And then there's how many rows? 6 rows. So minus 2 from the one below. And then we repeat this process here, minus 2, minus 2, and minus 2. Then the one below it. Okay, now what this represents here is that, I know this isn't super accurate here, but let's assume, for example here, that each one of these bricks, each one of these guys here on the bottom 3 rows, let's say they represent X amount of bricks. Okay, so you have X amount of bricks in the bottom 3 rows. Then let's take a look here at this row of blocks. So according to the problem here, how many bricks are in this row of blocks here specifically? How many bricks are in this fourth row of blocks that I've kind of highlighted here? So there's X bricks below it. So how many bricks are in that row? X minus 2. That's correct. Right? So there's X minus 2 bricks here in that row. Now, we want to go to the next row, and that has 2 fewer bricks than the one below it, which was already X minus 2. So how many bricks are in the row above that one? X minus 4, that's correct. Right? We have X minus 2, and then that's from the row below, and then we're subtracting another 2 from it. So we actually have X minus 4 bricks because of the, again, the definition of what they said for the last 6 rows. That would mean that this next one here is X minus 6. This is X minus 8. This is X minus 10. And this is X minus 12. So now we have, again, you just go up in order here. We have all of the rows there specifically. How many bricks? Now all we need to do is add these all together. Okay, so we're going to add all of these values here together. So we're going to have X. We're going to have X plus X plus X plus X minus 2 plus X minus 4 plus X minus 6 plus X minus 8 plus X minus 10 plus X minus 12. So we're going to add all those guys together. And somehow, automatically, they have to equal, how many bricks do we have here again? Check. We have, where are you? Oh, there you are, sorry. 156 blocks. So this should equal 156. All right. So again, now we can go ahead and add up our like terms here together and all the numbers that we see, and then we'll be able to do this problem out without too much trouble. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 x's. So we have 9 x's, and we have minus 2, minus 4 is minus 6, minus 6, minus 6 is minus 12, minus 12 and minus 8 is minus 20, minus 20 minus 10 is minus 30, minus 30 minus 12 is minus 42. Okay, so we have 9x minus 42 equals 156. And now we just go ahead and we can just do the rest of the problem, just using our normal algebra. So let's go ahead and add the 42 here. So I'll put this over here. So here we get 9x equals 198. Divide by 9. Let's cross that out. 198 divided by 9. What's that going to be? Uh, 22. Okay. Good. Okay. Go. Make sure we got our settings okay now. Okay. Yeah. 22 is correct. All right. Good. So if they ask you, okay, hey, you know, how many bricks are in each row? Okay, 22, 22, 22. And then you just go back in order here. You get 20 bricks, 18, 16, and so on and so forth. 14, 12, 10. Okay, good stuff. All right, good beans. All right, any questions? Any questions about that one? That problem there. Ooh, hello. All right, clear that out of my eye. Okay. Nope. All right, let's go ahead and try another problem then. All right, let's see, which one do I want to do? All right, let's give that a go. Okay, this is a classic problem here. Let's go ahead and try this one. Now, this one here is legitimately a little tough, but it is a good problem nonetheless. Where are you? There you go. All right. I'm not sure if I did this one, but I'll do this one anyway. Um, I don't think I did, but okay. Okay, so number 27. A conveyor belt 24 inches wide is moving boxes that are 12 inches wide and 18 inches long. Using the full width of the belt, how fast, in feet per minute, would the belt need to move in order to unload 6,400 boxes in an hour? Assume the boxes are placed end to end with no space in between them. All right. So let's do this one out here. All right. This one here requires a bit of things here. So let's at least draw it out here. So the conveyor belt is 24 inches wide, and we have 12 feet wide and 18-inch long boxes. Okay, and we want to unload 6,400 of these boxes. All right, so let's at least draw it out here. Again, sometimes drawing it out is kind of the best way to put it. So here we have the conveyor belt. All right, here's the conveyor belt. Looks pretty great. Um, Again, we know that the distance here for this conveyor belt is 24 inches. All right, we're also given boxes here. So we have a box here that has, say the box looks like this. Again, it's 12 inches wide and 18 inches long. Okay, that's for one box. All right. We want to move 6,400 boxes in an hour. And we're trying to find out how many feet per minute. That's what we're trying to find. Okay, that's what we want to do. All right, fine. So here's the question. So based on the picture that we have here, okay, how many boxes can fit side to side to cover the 24 inches that the conveyor belt can hold? How many boxes side to side can that conveyor belt hold? 2. That's right. So again, the first 12 inches, just kind of say, okay, I got the first box here, which is 12 inches. So, yeah. So let's say this is the first box here. That's 12 inches. And then you have the box next to it, which is also 12 inches, and there's no space in between them. So you got 12 and 12 here. And then you got 18 inches going up. All right. Now, if that's 2, okay, that means that we can have a pair of boxes running through this rollers here at all times. Okay, so this conveyor belt is going to run through, 2 at a time all the time. So one thing that we can take to the bank here is that if we want 6,400 boxes to move within an hour, all right, we need 6,400 divided by 2, since we can put 2 of these boxes together in a pair going down the conveyor belt. So we need 3,200 pairs of these boxes to go down. Okay, that's what we need. So we need 3,200 of these pairs of boxes in that 1 hour to go down the conveyor belt. All right, so that's the reasoning there so far. Now, what we need to determine here is how many inches those 3,200 pairs of boxes are going to be. And to do that, we're going to take a look here at the 18. Now in this case, the 18 here serves as a very important role. Remember, 18 here represents the total depth of the box, okay? Again, how long the box is. Okay, so we want to take, in this case here, let's find out what 18 is in terms of feet. So how many feet is 18 inches? Let's at least talk about that. All right, 1.5 feet. That's correct. So this is 1.5 feet. Now the reason why we say 1.5 feet is because we want our answer to be in feet per minute. That's what the question asks us to put it in. Okay, we're going to do what the question asks us here. Seems fair. All right, so we have 3,200 of these pairs of boxes going through, and each of them are a 1.5 feet long. So we're going to do 3,200 times a 1.5 feet, since we have 3,200 pairs of these boxes here. All right. And what do we get there in this case? All right, 4,800. Now let's take stock in what we have here. Okay, we had 6,400 boxes coming through in an hour. Now we have 4,800 feet worth of boxes coming through in an hour. Okay, that's what we want. We want 4,800 feet worth of boxes to come through in an hour. However, let's not forget the most important thing here is that now we want feet per minute, not feet per hour. We want feet per minute. And now we're going to go ahead and do the simple conversion here of changing hours into minutes. So that's the last little bit there that you have to be a little bit extra careful about, is that you're going to have 1 hour and then 60 minutes here on the bottom. So in fact, you're doing 4,800 feet divided by 60 here as the last part of the problem here. And so if we do that, we're going to get 80 feet per minute. Okay, and there we go. We got it. Yes, thank you. All right, are there any questions about that? Any questions whatsoever? That's a possibility, maybe. Guess you'll have to find out, I suppose. I'll just keep you in suspense. That's all I'll do. Don't worry, the problem's not as hard as you're making it out to be. Like I said, drawing a picture makes it very helpful. All right. So if there are no more questions here, this is where I'm going to end off here for today. Okay. And that means for Monday, we're going to go ahead and start with chapter 8. Okay, so chapter 8 is going to be for Monday. All right, so we're getting there, working our way nice and slow here for the last half of the book, and we're doing pretty good. Pretty happy so far. So far, so bueno. All right. All right. Okay. Nice work today, everybody. I want to thank everybody again for coming out here to the stream. It's very kind of you to even make some time for me. I really appreciate it. I want to wish everybody here on the stream a very wonderful weekend. Okay. Please take care of yourself as best as possible. Okay. Stay safe, stay healthy, and stay sane. All right. Don't let this don't let this COVID thing get you down. All right. I'm gonna be with you. All right. Be with you guys. We're gonna get through this together. All right. That's how it's gonna roll. All right. I'm glad this is better than the DMV. I'm very glad. Very glad. Okay. You guys have a wonderful weekend and have a wonderful night. All right. You guys take care and we'll see you later. Okay. Take care. All right.